Hello, my name is Quentin Odenthal. This video is my submission for question 4 of Group Project 2 of Computer Science A311. Alright, so I'm going to be comparing the space efficiency and lookup time efficiency of an uncompressed trie versus a compressed trie. So, if you compare them, it's pretty easy to see that the uncompressed trie right here has a lot less nodes than the regular trie uncompressed. Did I say uncompressed for this one? The compressed one has a lot less than the uncompressed right here. And that's because it likes to group letters together instead of just having one letter per node. And that eliminates these long chains where there's only one way to go and you're doing a lookup each time you go to the next node, and it's just really time inefficient and space inefficient because you have 3 nodes where you only really need 1 node because there's nowhere else to go. And that's how the compressed trie gets so few nodes. And it stores the same exact information. You input the same words in the same way in both of these, but this one ends up with, what is it, 1, 2, 3, 4, 5, 6 nodes, plus the head one. And then this one has 3, 6, 8, 10, 13. So you have 7 less nodes, same information, lookup time's much faster. It's more space efficient because it uses less nodes. And it's storing the same information, so you still have to store all those characters, but you don't have to store the next node, pointer, node pointer, for all of those other nodes that you eliminated, so you're saving a lot of space on those nodes that you get rid of. And it's lookup time efficient for a similar reason. You have less nodes, so let's go through a branch in the uncompressed, this guy. So you gotta look for A, and then you gotta look for B, and then you gotta look for A again, C, and then K. But for this one, you look for A, you find it, and then B is already attached to it, so you look for what's after B, and we went down that back, so you look for A again, boom, right there, and then you have the rest of your word. And so this one has 1, 2 lookups, or searches, right? Searches for A and then A again, and then you get your word. And this one has 1, 2, 3, 4, 5. So this one's going to be far quicker than this one's going to be. The caveat, I guess, is when you have to add a word, because for this one, the uncompressed, it's a lot easier than the compressed one, because you kind of just make yourself a new branch. Like if you want to do apple or something, you get P, P, L, E, and that's really easy. But if you wanted to do apple on this one, on the compressed one, you'd have to split AB node, this guy, into something like this. Okay, it's getting a little bit. That's good. So if you wanted to put apple in here, you'd have to split this AB up into something more like this, and then branch off with the P and the L and the E. And so you have to like make a new node, change this node, blah blah blah. But with this one, the uncompressed, you just have to put a P right there, and then you just keep going with it, and it's a lot quicker. But if you're talking space efficiency and lookup efficiency, which is what this problem's about, the compressed trie is so much better.